everyone, I am Kavitha Suresh Kumar, Senior Architect with IBM with over 22 years of experience in the software industry. I believe in the quote, knowledge increases by sharing and not saving. So I share the knowledge I gain by publishing videos and blogs. I'm an avid learner and I spend my free time in learning about the new technologies. And I'm very passionate about the technologies like Docker, Kubernetes and now operators. In today's session, myself and my friend Chitra will take you all through the operator journey. Chitra?
Hello all, I am Chitra Ananthanarayanan, Advisory Software Engineer with IBM. I have 16 years of industry experience and I've been working with the container orchestration platforms for the past 2 years. I developed an interest in operator last year and hope to give you a good experience in operators. Thank you, Kavitha.
I welcome you all to the Kubernetes Operators hands-on workshop. So let's check on the agenda on what all will be covered as part of this session. Right, so we will give a brief introduction on what is an operator and why operators are required and how they are useful. Also, we will touch upon the operator capability levels. We will provide you information on what are the advantages of using operators and the best practices the user need to consider while writing an operator. Also, we'll give a brief introduction on the operator framework components and how the operator SDK enables the user in building operators quickly and easily. We will also show you how to discover and deploy an operator from the Operator Hub. So here we will use the Operator Developer Console and we will show you option on how to discover an operator and deploy an operator by following the few steps. Also, we will give a walkthrough on how to package an operator as an OLM bundle. And then we will take you through the hands-on session. We will provide the necessary information on the hands-on and what all you will learn by executing those hands-on. Okay, so let's get started. So what is an operator? So an operator is actually in general is a person who performs specific operation with specific skills. So, but what is a Kubernetes operator? Kubernetes operator, in case of Kubernetes operator, the human knowledge is codified into software to manage complex applications. As you can see in this diagram, here you can see the expert knowledge is codified into the operator, and the operator in turn communicates with the Kubernetes APIs and uses the primitives provided by the Kubernetes and performs the application specific operations and then update the status of the custom resource. So that there are multiple definitions for the Kubernetes operators. So we can call it is a method of packaging, deploying and managing a Kubernetes native application. Also we can say it is an actually application specific controller that extends the Kubernetes API and then which helps to create, configure and manage the complex applications. So the Kubernetes operator is basically built upon the Kubernetes concepts like resources and controllers. Along with that, it has the domain or the expert knowledge packaged into the operator to automate the complete lifecycle of a software, right? So what is actually a Kubernetes resource? The Kubernetes resource is the endpoint API, endpoint of the Kubernetes API that stores a collection of API objects of a certain kind. So what is a controller? So actually it is a control loop from the Kubernetes terminology perspective. So if you see, it is going to watch the current cluster state and it moves the Kubernetes to the current cluster state to the desired cluster state. So there are multiple definitions for the Kubernetes operators. So we can call the Kubernetes operator is a method of packaging, deploying and managing the Kubernetes application. We can also call it as an application specific controller that extends the Kubernetes API to create, configure and manage complex applications, right? So it is built upon the basic Kubernetes resource and the controller concepts. Along with that, the domain knowledge and the application knowledge is embedded into the operator to automate the lifecycle of the software, right? So resource plus controller plus knowledge equal to an operator. So there are different definitions for the Kubernetes operators. So the Kubernetes operator is a method of called packaging, Kubernetes operators. So there are multiple definitions for the Kubernetes operators. We can call it as it's a method of packaging, deploying and managing the Kubernetes applications. And also we can call it as an application specific controller that extends the Kubernetes API to create, configure and manage complex Kubernetes applications. It is actually built upon the Kubernetes concepts of the resource and controller, but it also has the domain expect knowledge to built into the operator to automate the entire life cycle of the software. So what is a Kubernetes resource? So the Kubernetes resource is an endpoint of the Kubernetes API that stores the collection of API objects of a specific kind. For example, you can say pod is a resource and the deployment is a resource. Then controller. So controller is a control loop. So before going into the Kubernetes controller concept, let's talk about the basic control loop concept. Let's take an example of a thermostat, right? So when you set a temperature, so that the temperature what you set is a desired state. So the current room temperature is the current state, and the thermostat acts to bring the current state as close to the desired state by on and off the equipment, right? So similarly, in case of Kubernetes controller, it actually monitors the current state of the cluster and it tries to bring the current state as close to the desired state of the cluster. And then knowledge. So this is about the domain application specific knowledge, which is actually learned from a domain and application specific expert. So the resource plus controller plus the knowledge is actually equal to an operator. Let's delve more deep into the Kubernetes controller, right? So the Kubernetes controller, as we all know, it is actually a software loop, right? So here, and we call it also as reconciler loop, right? So we have a reconcile method. So let's now focus more on the Kubernetes controller. So actually it is a software loop, right? So here, as you can see, it is even called as a reconciler loop. So you have a reconcile module, so which is invoked periodically, which checks whether the current state of the cluster is matching with the desired state of the cluster. And also we have something called as an informer, which keeps on watching the custom resource. And when the user makes any changes to the custom resource, it informs the controller about it. Generally, this controller is run as a pod in the Kubernetes cluster. So the controller is a continuously running process. It checks for the current state and the desired state of the cluster. So if there is any difference between the current and the desired state, it takes a necessary action. Like for example, in case if the custom resource, the user has changed the number of replicas from 3 to 2, right? So in this case, the controller will initiate the action and it will delete one of the pod, so that now will be only 2 pods will be running. So that's all about the Kubernetes cluster controller. So now Chitra will take you through why operators are required.
Yes. So when did we feel we need an operator? So when we started adopting Kubernetes, it was all stateless applications and they could be managed by the built-in kinds that came with Kubernetes, the deployments, the pods. So all that was needed was scaling. And then we started moving to the stateful applications, but then they were simple databases that needed only a single instance. And yes, it was possible to manage that too, using the stateful set and the persistent volume. And then came in the distributed applications. So these applications are complex. They have multiple tiers, multiple components, and they require data rebalancing, a smarter auto scaling, and they also require certain auto healing and seamless upgrades. So when all this came in, the need for an SME or an SRE, a site reliability engineer, at the sites where this applications was deployed was required. The need for the SME was felt here. Now we have a number of such distributed applications running on Kubernetes. Kubernetes cannot manage each such application. It cannot have knowledge about all such applications, right? So Kubernetes provides us certain basics, certain abstractions, such as the replication, the ones for scaling, the ones for scheduling, and for this failover automation. And on top of it, it provided us an extension mechanism so that we can extend it by adding application-specific knowledge. So when your application is deployed, when the knowledge corresponding to that SME is embedded into a controller, then the application becomes capable of taking care of your application. So that's what is the operator. So what you have is, we have the resources that come with Kubernetes, something like pods, something like deployments. So we bring up custom resources. And at the same time, we've been having controllers that come with Kubernetes. On top of that, we start providing our custom controllers. So these custom controllers will manage our custom resources. They will have the logic to manage our custom resources. So let's see how this happens with a Couchbase database, which is also a distributed application. So all that you will need to provision a Couchbase database is just give it a CR with certain a custom resource with certain high-level details about the application. And when the custom controller, the operator that manages this custom resource gets it, it will perform the operations. It will invoke the Kubernetes API to perform certain operations, such as creating a stateful set. And it will also perform certain other application-specific operations. So for example, if you want to increase the number of replicas by 1, this controller, your custom controller, the operator, it is capable of performing the Kubernetes API activity of adding one more pod, and it is also capable of doing the domain-specific operations, such as adding one more node to the Couchbase cluster and performing the data rebalancing. In this way, each operator can manage the application for which it is specifically built. We'll move to the next slide. So when we hear of an operator, it's important for us to understand the capability. What all can this operator do for me? So can this operator only do the install, or will it be able to upgrade to the next level? Will it be capable of managing the lifecycle management events, such as taking a backup, restoring it? Will it be able to give me deep insights? Will it be able to provide me events? Can it go along with the metering component and provide me details on the billing? Will it be able to do all that? And also, can it go to a higher level of auto-tuning itself, find out errors in the application and auto-correct them? So how can we find out these details? That's where the operator capability levels come into picture. This is previously called as the operator maturity model. It gives us certain guidance in finding out, in expressing what all we can expect from an operator. You can also find certain further details here that we can develop operators using 3 languages, the Go, the Ansible, and the Helm. And you also find that while the Go and Ansible operators can reach up to level 5, the Helm operators can reach up to level 2 only. Let's now move to the advantages. So yes, there are a number of advantages while using operators, and that's why we are talking about it. So when you develop an operator for your application can be deployed on any Kubernetes environment and it can run there. Your customers can make use of the Kubernetes utilities such as the kubectl and the dashboard to get details about your operator as well. Not only that, your customer need not spend time in maintaining your application. If there are any errors, they need not come to you. Your operator, which has your logic in it, will be capable of fixing it by itself. Also, operators add a huge value when the applications are deployed on multi-cloud or hybrid cloud, because your customers' employees, they need not know about the various infrastructure environments such as the Azure, AWS or IBM cloud. Your operator will take care of it by itself. Finally, you are the one writing your operator. So you can extend it to whatever level you want. You can add logic to it such that it can take corrective actions whenever it finds some details about some failure events. That way, you make your operator much more valuable. So whenever we write an operator, it's always better to follow certain best practices. We have a few and you will learn more as you develop them. So whenever you have an application, create one operator corresponding to your application. Your application may have multiple features, so add a controller corresponding to each feature, and each controller should have one CRD. Also, try to use built-in kinds such as the pods wherever possible in the custom resources that you use, because these built-in types, they've already been tested and they're proven. It's always good to use some tool such as the operator SDK to create your operator, because these tools enable us to develop the operators real quick. There are certain other runtime best practices as well. So we will be providing details about the status, the observed state of the custom resource in the status. So ensure that you provide meaningful details there so that your customers will be able to understand it. Whenever you develop an operator, ensure that it will be able to move itself up, upgrade itself from the previous version, and it will also be able to upgrade the operands from the previous version. Also, ensure that you develop an operator version corresponding to your application version. So there should be a one-to-one correspondence between your operator version and the application version so that it will be seamless and it will be easier for the user to understand.
Now let's talk about the operator framework. So operator framework is an open source toolkit for managing the Kubernetes native applications called operators in an effective, automated and scalable way. Right? So the operator framework, it has three pillars. One is the operator SDK, which is the software development toolkit for writing operators. So which helps the user to build, test and iterate and package the operator. So the next is we have the operator lifecycle manager, so which is the management framework that extends the Kubernetes with operators. So which provides a declarative UI which will enable the user to install, manage and update the operator and its dependencies. And the third pillar is the operator hub.io, so which is actually the registry for the Kubernetes operators. So where the Kubernetes community users can publish and share the operators. So what is an operator SDK? So the operator SDK is a framework that helps the user to build, test and package the operator. So it is a framework that actually uses the controller runtime library to make writing operators easier by providing the high-level APIs and abstractions so that the user will be able to write the operational logic more intuitively. Right? It also provides the scaffolding and the code generation so that anyone who wanted to build an operator using the operator SDK, so they will be able to kickstart building the operator, because operator SDK is going to provide the necessary scaffolding and the basic the code generation, what is required by the operator. It provides options where the custom logic can be added by the user. Also, the operator SDK, it provides the extensions for the common operator use cases. So let's talk about the second pillar of the operator framework, which is the operator lifecycle manager. So the operator lifecycle manager actually extends the Kubernetes to provide a declarative way to install, manage and upgrade the operator and its dependencies. To be precise, so actually the operator lifecycle manager is a set of cluster resources that actually manages the lifecycle of an operator. So the operator lifecycle manager has a rich set of features. It provides support for the over-the-air updates and catalogs. So with the operator lifecycle manager, with the rich update mechanisms, it ensures that your operator and your cluster is always up to date automatically. Using this rich update mechanisms and the dependency model, right? The package manifest, which is available with the operator lifecycle manager, which enables the operators to add their dependency information about like which operators they are depend on and what are the dependencies they have on the platform. So all these dependency information can be provided in the package manifest. And the discoverability. So this operator lifecycle manager, so it ensures, it gives the options for the user to publish their operators. So it again enables the users to discover the operators which are available for the users to use, and they can just select, discover and install. Cluster stability. The operator lifecycle manager, so it avoids the conflict, it avoids the installation of the conflicting operators which share the same APIs. So thereby ensuring the cluster is always stable. Right? So then it has declarative UI controls. So the operator lifecycle manager, so it allows the operators to be considered as a managed service provider by the APIs which are exposed by them. So as we already discussed, that operator lifecycle manager is a set of cluster resources. Let's drill little more detail of that, right? Let's see what are the resources comprised of the operator lifecycle manager. The first one is the cluster service version. Actually, it is a YAML file. It's a metadata file. So this metadata file is packaged along with the operator container image. And it has almost all the information which are required even to provide the information required in the user interface. For example, in case of operator hub, when a particular operator is published, so it provides the information about the particular operator. It gives the information about like what is the logo, what is the description, what is the version, and how to run the operator, right? So all these information and the technical information on how to run the operator is actually provided as part of the cluster service version. It also has the information about the RBAC rules and what are the custom resource the particular operator manages and it depends on. The second cluster resource, the CRD, the custom resource definition of the OLM is the catalog source. Actually, it's a metadata, right? It's a collection of operator metadata. Like it has the metadata information like the cluster service version and the custom resource definition and the package manifest. The operator lifecycle manager actually uses the catalog source to discover and install the operator and its dependencies, because it gets all the necessary informations from the cluster service version and the CRDs, and using which the operator lifecycle manager will be able to install the operator. The next one is an install plan. Actually, it is a calculated list of resources that has to be created to automatically install and upgrade a CSV. So let's move on to the other custom resource definition, that is a subscription, right? So subscription actually describes like to which channel of an operator package the user want to subscribe to and whether they wanted to perform the updates automatically or manually, right? When you create a subscription with automatic, so your operator will be always running with the latest version, because the operator lifecycle manager takes care whenever a new version is published, right, in a particular channel to which you have subscribed to. But if you have mentioned it is a manual, then it expects an approval from the user to approve so that it can upgrade from the current version to the newer version. Then we have something called as an operator group, right? So the operator group, it actually configures all the operators deployed in a particular namespace as the operator group object, so that it can monitor all the custom resources which are deployed in the particular list of namespaces or in the cluster wide. Then the package manifest. Actually, it is an entry in the catalog source, right? And the OLM uses and it provides OLM with all the information that is required to update a CSV to the latest version in a channel. So now we'll talk about the third pillar of the operator framework, which is the operator hub.io. Actually, it is a registry of the Kubernetes operator. So we can consider it as a home for the Kubernetes community to share their operators, right? So here the operator developers, they will be able to build their operator and they will be able to publish the operators in the operator hub by providing some information on how the operator can be deployed to the users with some little in documentation. And also the developers who wanted to make use of these operators, they can just go to the operator hub. So they will have the basic documentation on what is the operator is all about and what are the features this particular operator has. So they will be able to use that information and then they'll be able to deploy the operator. So now we will have a small walkthrough on how to discover and deploy an operator from the operator hub. Okay, so from the we are in the slide discover and deploy an operator from the operator hub. So now we'll play a video of the demo. So what you're seeing is the operator hub. So this is from the OpenShift developer console. So the operator hub, it has the multiple filtering criteria. So you'll be able to filter the operators based on the provider type, provider, etc. So for this demo purpose, we will select the community operator, right? So we are going to install the 3-scale API management community operator. So you can see in the screen, it has a lot of information about the particular operator, the capability levels, the operator version. So click install. So when you click install, it is going to ask you to provide the information about like which channel you want to subscribe to and what do you want the installation mode and what is the namespace. So here we are selecting the default namespace, and we are going to select the approval strategy as manual. So which means the manual intervention is required when we are going to for installing this operator. So click install. And here we can see as part of the install operator, so it says upgrade pending, because it's like we have given the install plan approval strategy as manual, right? So here when the subscription is automatically created when you click install, along with that an install plan is created. So in the install plan you can clearly see it's like preview install plan and it requires approval, right? So you go and click components, and then you can review the install plan and then provide your approval. So once the approval is provided, it is going to start the installation of the operator. So when you go and check in the installed operators place, you can see the installation has got started, because since you have provided approval, it has started the installation. Now let's go to the projects. We deployed projects is equivalent to the namespace. So we get given the namespace as default. So we can go and check the deployment. So the deployment, what it is going to come is the one which is going to show what is the operator which is getting deployed. So clearly we can see there is this Rescale operator, and then we can see it is like one pods is running as part of this deployment. And when you go to the installed operators, you can clearly see this operator has been deployed, right? And we can see all the necessary information about this particular operator, like what are the APIs they support, and you can see the all other information about the description and what are the features supported. And in the bottom, we can see about the cluster service version details, right? And what is the status of it, and what is the operator group, right? So all these informations are available. And then let's now first review the YAML file, which is the cluster service version. So as we mentioned earlier, right? So all the information, what is available even in the operator hub, the documentation, all these information comes from this cluster service version YAML. So you can see the custom resource definition. So this has all the information about all the APIs supported by these operators, right? And then you can clearly see like you have a separate tab where you'll be able to create an instance of a separate API, but we will just go to all instances and provision one of the create tenant API, right? So you can see here it has some default values, so you can update them, and then you can click create. So when you click create, actually we are creating a custom resource which is provided by this Rescale API management operator. So you can go to the all instances and you can see that the particular instance has been created.
Thank you, Kavitha, for showing us how soon and how easy we can provision an application when it has an operator. So yes, we will now see how these two components, the operator SDK and the operator lifecycle manager, enable us, make it easy for us to develop operators. So as a developer, you come and we make use of the operator SDK. We say that we want a new project. So it creates a new project in Golang for us, for the operator. So it generates a scaffolding, the skeletal code in the Golang corresponding to the Kubernetes runtime. So this is what it generates for us. Along with that, it also provides us certain placeholders where we will have to add our custom logic. So we spoke about the custom resources and we also spoke about the custom controller, right? So our custom resource will have some application specific fields in it. So that has to be added to the API. And how to manage this custom resource? That has to be added to the reconcile method. So there are placeholders for adding this. So the developer has to provide these values. So once he has provided these values, he can run certain commands that are available from the operator SDK. The operator SDK makes use of the make utility and provides certain commands there. So he has to issue a couple of commands like the make generate and make manifest, which will add code, or rather update code to certain files, and will also generate certain manifests. Specifically the CRD manifest, the custom resource definition manifest. So this is what we will be exploring in our first hands-on. In fact, you will be deploying that CRD and you will also be creating the custom resources there. So In the long run, our operator will become a deployment. It will become a deployment on the Kubernetes, just like how we saw it on the OpenShift. So we need to create an image corresponding to our operator. So there are some commands that are available from the operator SDK that make it easier for us to build that image as well. Once this image is built, we have to push it into an image registry so that it can be used later in the Kubernetes environments. After pushing this image, we need to generate certain manifests, certain metadata about our operator so that the operator lifecycle manager will be able to update those details. So there are commands available from the operator SDK for that as well, and we will be seeing them in the next demo. So using those commands, we will generate these manifests. After generating them, we need to add certain additional details to them so that it will be easier for the end user to use our operator. After adding that, again, we need to build a container image out of those manifests and push it into a registry such that the OLM can pick it up. Then we have to make use of another tool called as the OPM, Operator Package Manager. And this tool will be used in order to add our manifest, the manifest that we have prepared, right? The metadata that we have prepared, we have to add it to a container image. This container image is being used by the OLM. And this container image has a database of references to such manifests, to manifests corresponding to operators. So we will have to add it to one such image, or we can create our own image. So if we create our own image, we will have to inform about it to the OLM using a new catalog source. So yes, we have completed developing our operator. It is ready, and so it is being made use of by a Kubernetes administrator now. So the Kubernetes administrator, he'll have to prepare a new catalog source if our operator is new, and he need not do that if it is part of the one of the four sources that we already saw, right? So something like this, the community operators, the ones from Red Hat and so on, he need not add it. Otherwise, he has to add a catalog source and inform about our new operator to the OLM. So as we saw, the OLM, the Operator Lifecycle Manager, is itself another operator whose primary purpose is to acquire, deploy and manage other operators. The end user, he just has to come to the OLM, he'll be able to list the manifests, and he has to decide which operator he requires. He creates a subscription to it by providing a channel. A channel is a stream of releases. By providing a channel and also providing his approval options. Once he does that, the operator will get deployed in the Kubernetes cluster, and then you can create managed applications by using this operator. And this is what we just saw in the hands-on. You saw how easy it became an experience for the end user when the application is into an operator, and it can be directly deployed using the operator hub. Now here we will be going on to view a demo on how we can make use of the operator SDK to generate certain manifests which will provide details about our operator to the operator lifecycle manager. So we will be moving to the demo now. We are at the use operator SDK to create operator manifests related to OLM. So we are at the podsets operator. So this is the same one that we will be using in our demonstration. We see that there are some configuration parameters in the make file for which we have to provide appropriate values as they will be used in the images getting created. Our controller will become a deployment, and hence we need to build the controller, and we need to add the binary in order to a container image so that it can be used by the operator lifecycle manager. It can be used in Kubernetes. So we have commands from the operator SDK to do this, and we are creating an image out of the binary. Now once we have created the image, we have to push it to a container registry such as the quay.io or the hub.docker.com. And then we have to generate the manifest corresponding to our application. We will be using the bundle manifest here, and we are generating the bundle manifest. This is one of the manifests that is recognized by the OLM. So once we create the bundle manifest, we are able to see the cluster service versions and the CRDs getting generated here. We can add additional data to them in order to make our custom resource more usable by the end user. Once we provide this, we need to package these bundles, these manifests, again into another container image and then push it into a registry. A utility file has been generated for this purpose for us by the operator SDK itself. We will use that and we will be creating a container image with these metadata. Now, once we create this image, we have to push it to a registry once again, and we have to add details about this bundle to another container image that is being used by the catalog source in the operator lifecycle manager. We will be adding it by using a tool called as OPM, the operator package manager. We can create a new such image, or we can use an image that already is present and is being used by the OLM. And now let's have a quick overview on the hands-on that we will be performing. So we are on the hands-on one slide, develop a Go operator using the operator SDK. In this hands-on, we will be using this link here, and we will be developing a simple operator called as the pod set operator, which manages a set of pods. It takes the number of pods as input from the user in the replicas field, and it provides the pod names, the names of the pods that it manages in the status field. So we will add relevant logic in the reconcile method to ensure that it manages the specific number of pods, and we will also test it in the developer environment itself. So we will be initializing the operator SDK, and we will also be creating the API. We will instruct it to create the resources and the controller for us, and we will be adding in details to the pod set spec regarding the number of related to the number of replicas that has to be created, and we will be providing the pod names as an input in the pod set status, because this is the output that can be expected by the user from our controller. So after adding these details, we will execute a couple of commands to generate the CRDs and to generate certain custom code. And once that's done, we can update our reconciler logic. So in the reconcile is the method that's a key method in the controller, and this is the method that will be called whenever a pod set is added, updated, or it is removed. So please check the logic here on how it counts the number of pods that are created by this pod set. Please check how it updates the status, and also check on how it creates or deletes a pod when it finds a difference between the actual state and the desired state. Also check how it provides the status, how it provides the return value, how it shows a success by returning the result with a nil, and how it shows an error when it returns the result with an error, and how it says requeue, which means that this reconcile method has to be called once again. Also check on the methods that add a new pod and the method setup with manager, because they show you how a new pod is created with appropriate names, and how it provides a list of objects, a list of resources that are being watched on by this controller.
Okay, so let's move on to the hands-on too. So here we will explore like how using the OLM will be able to create a custom resource. So we already saw the walkthrough or from the operator hub, so how we can use the OLM and then create a custom resource. So in this hands-on, we are going to see like how we can do the same thing through the command line interface, right? So when you click the create custom resource online, so it is going to take you to this page. So where you are going to perform the hands-on operation, right? So as part of this operator lifecycle manager hands-on, so it is going to provide you the different options on like how you'll be able to find what are the operators available, right? So what are the different catalog sources? So when you check for the catalog sources, you will be getting the sources like Red Hat operators, community operators. So from that, again, you can find the package manifest of the different operators, which is part of a different catalog source. And then you can actually create a operator, deploy an operator. So primarily when you do this operation through the CLI, these are the basic steps what you do. So the first step is like first you'll be creating a project, which means it's a namespace, because that is the space where actually you're going to deploy your operator. So then you'll be creating an operator group. So in that operator group, you'll be specifying the namespace, as well as the target namespace where you wanted to monitor the custom resources. Then you'll be creating a subscription. So in this case, we were going to deploy the Argo CD community operator. So through the channel as alpha, and then the install plan approval is again manual, right? So which means an approval is required before the operator can be deployed, right? So once you create a subscription, along with the subscription, an install plan gets created, right? And then you need to go and update the install plan. And then when you update the install plan with the status as approved, then it is going to create all other custom resources which is associated with that operator. So once we have all the necessary resources created, including the RBAC, role bindings, everything, and the operator is successfully deployed, now you can go and create the custom resource. So in this case, it's an Argo CD resource. So what you are seeing in the right hand side, we are going to create an Argo CD custom resource with a name example Argo CD, and the spec, it has a set of parameters, options which you can provide. So you can modify, and based on these are the parameters which the custom resource accepts. So you can provide that information, and then you will be able to create the custom resource. So using a CLI, you will be able to create a custom resource just by providing certain information and by getting the necessary informations what is already available in the operator hub.
So we just had an overview of the operators. We saw how they emerged. We also went through the operator framework, the operator capability model. We had a couple of demos on them, and now we are going to work on them during the hands-on. We hope you like operators, and we hope you enjoy developing them. So these are certain reference links which will enable you to get further information about the operators, and they'll also provide you further details on how you can develop them. They'll be useful to you, and we request you to go through them. Thank you.